Welcome back. Today we're going to be taking a look at the very first commercially available NACS to CCS1 extension cable. It's made by a company called Hansshow. First off, why would anybody want a NACS to CCS1 extension cable? Well, now that many, if not all of the automakers are getting access to Tesla Superchargers, they're realizing that some of the charge port locations are not conducive to plugging into Tesla Superchargers. The Superchargers were designed for Tesla vehicles, and Tesla vehicles all have their charge port on the left rear of the vehicle. They back into a charging stall, and the short cable on the Tesla Superchargers plugs right into their inlet. However, a lot of the other electric vehicles have charge ports in different locations, and some of them just simply won't reach the Tesla Supercharger connector, won't reach the charging inlet unless the vehicle takes up 2 parking stalls. So that's a problem for a number of reasons. Number one, you don't want to take up 2 stalls while you're charging. But number two, if you go to a Tesla Supercharger site that has high utilization, you need to get 2 spots next to each other that are open in order for you to be able to pull in and plug in. And that can be problematic. You know, you might get 1 spot and then somebody pulls in the other spot before you can take it and get 2 spots. It's troublesome. I've had that problem already where I had to wait quite a bit to get 2 stalls open next to each other. So I think that's probably as big a reason as any to want to consider getting an extension cord. So, and this one's made by Hansshow. They make accessories for Teslas and other electric vehicles. This is their first product like this, and as I mentioned, it's actually the first one to hit the market from any manufacturer. There's a few other ones that are in production right now and testing. I've done some videos from the one made by A to Z. I did a little beta testing with one of those. It's not available for purchase yet, but this one you can buy now. It costs $599, which is quite expensive. However, it does have the integrated CCS1 plug on the other side. The other extension cables that I've looked at don't have the connector. You need to then use a NACS to CCS1 connector. So this includes it for $599. However, it includes it and it's still only 60 inches long. I don't think this is going to be long enough for many of the electric vehicles that are on the market today. And I'll be able to test one of the most difficult ones is the Ford F-150 Lightning, because that has a very long distance from the end of the vehicle to where the charge port and a real long front hood. So I'll be able to see if this reaches. The goal is you should be able to stay in a single parking stall or use the stall that supercharger was designed to service. If you have to park halfway into the other stall, then the extension cable is useless. If you can't park any electric vehicle in the single stall, as far as I'm concerned, it's a fail. So we'll see. Hopefully it will reach. I'm thinking it's going to be a little short. I think you need about 6 feet when you include the adapter in order to be able to reach cars like the Lucid Air and my vehicle. But we'll test that out really soon. Basically, what I want to look at for this to tell if it's useful are 3 things. Is it long enough? Does it work? Does it charge the vehicle at full rate or even at a reduced rate? It's only rated for 250 amps. That's what it says on the website. Many electric vehicles today pull more than 250 amps. Some pull 500 amps for extended period of times. Now, the 2 vehicles I'll be testing this with, my Rivina R1S and my Ford F-150 Lightning, can both pull 500 amps for a short period of time. So we'll see how it reacts with those 2 vehicles. So we have the length, we have does it work, and then safety. There's some things that raise some concerns with this product, which we'll talk about next. You know, even if it works, if it's not safe, I wouldn't recommend purchasing it, but we'll get into that shortly, and then I'll drive up to a Tesla Supercharger and test it out on a couple vehicles, and we'll see how well this guy works. So let's get into it. Okay, so before we go test it, let's talk a little bit about the specifications. As I mentioned, it's 60 inches long from end to end, and that's including both connector. So the cable really isn't that long. And when you have to plug this into a CCS equipped vehicle, the cable is going to stick out a little. It's not very bendable. So I think you're only going to end up getting about 4 feet of extension, but we'll see that when we get out in the field. It has 2 thermal sensors. I would assume one's on each end. If the internal temperature at those sensors hits 185 degrees Fahrenheit, which I believe is 85 Celsius, the charging will shut off. So that's the safety that they have inside as far as for overheating. You press this button on the CCS one end to stop charging, or you can stop charging from within your vehicle or from the Tesla app or the native app from your car company. That's how you have to stop charging. Unfortunately, on the other end, the NACS end, where I could probably get a NACS connector over here to demonstrate, the supercharger connectors are basically the same. They're a little bit different. The cable's a lot different. Press this button and let me see what I'm going the wrong way. Okay, so here's a supercharger cable plugged in, and this is plugged into your vehicle. It has a switch here. Not a switch, I'm sorry. It has a release button, but unfortunately, that's all it does is release the connector. It does not stop charging. This is a major safety issue. Now, Hansshow does specify in their instructions, and they even have a video. They remind you, you have to use this switch here or the vehicle to shut off charging. You can't shut it off from here. They're pretty clear with that warning. But the problem is people don't follow instructions. And as far as I'm concerned, if you can press this button and remove this connector while charging is going on, that's a big safety problem, and it shouldn't be. There's got to be a switch inside here that shuts charging off the minute this is depressed, like it is on the adapters. Pretty much all of the adapters that are on the market, the NACS to CCS1 adapters, if you press either switch, it's going to immediately shut off charging. It's like that way with pretty much all of the connectors on the market. If you press this button, it shuts off. This button here, it shuts off. This needs to stop charging. If you don't, what you can have is a serious arc flash. When you depress this, if you pull that out fast enough, you could have a serious problem. You could really get hurt. So that's a problem that I have with this. I think it's something that Hansshow needs to address. I don't think it would be a monumental task for them to add a safety switch in there to shut off charging, but nonetheless, it doesn't have it. So if you do buy one of these, make sure that you do not press this button and try to remove the NACS connector while you're charging. Shut it off the proper way, either by in your vehicle, your Tesla app, or you press the button on the CCS handle and that will stop charging. Remove this from your vehicle so you know no power is passing through it. Then remove this from this end and holster the connector. So that's the basics. So now first up, what I'm going to do is test the length. I'll take my Lightning up to a Tesla Supercharger and see how the length works. I'm not as concerned with my Rivian because the Rivian's charge port is located much closer to the front of the vehicle. I think it'll work on that. But for the Lightning, that's a very good litmus test on whether it'll work on some of the vehicles that have long hoods, like a Cadillac Lyriq, Lucid Air. There's some Audi vehicles that have long hoods with the charge port on the left front fender. Those vehicles, I think, are going to have problems with this, and we'll test it out with the Lightning. If the Lightning reaches, I think those vehicles will reach also. If it doesn't, then, as far as I'm concerned, that's one strike against it because it needs to be able to service all vehicles, I think. I think if you're going to make an extension cable, any electric vehicle on the market should be able to use it and only occupy a single stall. Otherwise, it's just poorly engineered as far as I'm concerned. All right, we'll head up to a supercharger now with my Lightning and see if it reaches. State of Charge is powered by Qmerit, North America's premier installer of electric vehicle charging equipment. After I've helped you decide which charger to buy, follow the link in the description of my videos and have Qmerit install it. And if you do follow that link, Cumer will waive the $150 installation deposit. But this is an exclusive offer for State of Charge followers. So in order to get that offer, you must follow the link in the description of my videos. All right, so I'm up here at a Tesla Supercharger. I pulled my Lightning into the stall all the way to the right side of the stall, to the point where my tires are practically touching the white line on the other side. I wanted to get as far over to the right as I possibly could, but still be within the stall. Now let me get out the Hansshow extension cable, and we'll see if it reaches. Now you may notice that I also pulled beyond the curb with the front of the Lightning. And that's because I can do it at this site. At some Tesla Supercharger sites, the bollards are all the way at the front of the curb line. And I wouldn't be able to pull, geez, about 14 inches farther than I did right now, or not as far as I did right now. And if you notice here, there's a concrete strip on the front of the superchargers here. And that's because when this site was originally installed, the bollards were up here against the curb line. But since Tesla opened up the supercharger network to other vehicles, recognizing there's a problem with them reaching, they sent a crew out, saw cut the concrete here, removed the bollards, and pushed them back about 16 inches. So that allows me to pull up about 16 inches farther than I could before. If the bollards were at the front of this, I'm pretty sure this thing wouldn't reach. It's going to be close right now, but let's see. Okay. So it does look like it will reach. And it does. It actually has a few inches to spare. So a Lightning will reach, at least at this site. All the Tesla Supercharger sites are slightly different, and the positioning of the bollards is going to make a big difference. I'm not sure if this bollard was at the front of the curb line where it was just last year. I don't know if I'd be able to reach and stay within this stall. All right, well, that's all I wanted to come up here today for, was just to test if it would reach my Lightning, and it does, so it passes that test. Not going to do a full charge recording here because my Lightning's at a high state of charge. What I want to do is record the Lightning and my Rivina R1S from low states of charge, like a 10% starting point to a set ending point. I'm going to do it with just an adapter and record the charging session, then do it again from 10 to the same finishing point with the Hansshow extension cable. We're going to compare the results of the charging sessions with and without the extension cable. So I decided to test out the Rivina R1S before the Lightning because the Lightning was at a high state of charge. My Rivina was at a low state of charge. So I actually drove it down to 0 and went back to that same supercharger, which is in Alamucci, New Jersey. It's a V3 Tesla Supercharger site, and I plugged in the extension cable. However, after only about 2 minutes of charging, we were only at 4% state of charge, the vehicle stopped charging and said that it was too hot. So what I did was I unplugged everything, let it cool for about 15 minutes, pulled a couple stalls over, plugged it in, and this time it shut off within a minute. So now I thought that I probably need to test it at another supercharger site just to be certain that it wasn't that supercharger site. Now I charge my vehicles up at the Alamucci Supercharger frequently and never have an issue with them. And you saw me plugging in the Lightning with the extension cable just to test out the length of it. And I actually let it charge for about 10 minutes and it had no problem. So I just wanted to confirm that the Rivina, for whatever reason, doesn't like playing with the cable. So I took it to the Rockaway Supercharger station, which is about 20 minutes away from the Alamucci one. And that's one of the new V4 supercharger station. Just opened up a couple of months ago. It's really V3.5, but it has the V4 dispensers. And I know all the equipment is new. All the connectors on the cables are all brand new, so I should have no problems with that. And I first did the recording with a NACS adapter with the R1S. And I did a 10% to 60% recording, and it took 26 minutes. It charged from 10 to 60% in 26 minutes. I then drove down the Rivian over the next couple of days down to 10%, plugged it in again to repeat the test, and it charged from 10% to 34% before charging stopped. And it only lasted for 12 minutes. Now, I didn't get that display that the inlet was too hot. It just stopped charging. I waited a few minutes, plugged it back in. It wouldn't even accept charging at that point. So the only thing I can say is we did hold the full 200 kilowatts for the entire charging session. They charged at over 200 kilowatts for those 12 minutes. But then it shut off, and the Rivian didn't want any part of the extension cable, did not want to begin charging again with it. So for whatever reason, the Rivian does not like when this is being used. It will not accept charging, at least in the times that I have done it. And this is at 2 different supercharger sites. So next up was testing the F-150 Lightning. All right, so I'm here with my Lightning at a Tesla Supercharger. This is one of the V4 superchargers, well, they're V3.5 right now until Tesla installs the V4 power cabinets. Right now, the dispensers are V4. And the good thing about that is I don't need an extension cable to charge my Lightning. It'll charge without the extension cable, but we have it here and we're testing it, so let's give it a shot. Now, just yesterday, I charged the Lightning here from 10 to 50%, and it took 24 minutes. So I want to see exactly what it takes with the extension cable, and if the extension cable will work for the full 24 minutes or however long it takes to charge a Lightning. We saw with the Rivian that it shut off, it overheated. Now, I also brought my thermometer, so we're going to check the cable before and during the charging session. I'm going to test it every 5 minutes or so. But to start off, the cable says that it is 97.5 degrees Fahrenheit. And it was cooler. That just warmed up from sitting out here for a couple minutes, because when I drove over, I had it in the cabin of the Lightning. I didn't put it in the front because I know it would have been hotter in there, so I kept it in the air-conditioned cabin. So even after sitting out here for a couple minutes, it's still under 100 degrees Fahrenheit. Let's see how it works. Let me make sure it's initiating. Nothing yet. I have the plug-in charge activated, so it should just immediately start charging. Yes, we are charging now. It took a little bit longer than it typically does with the adapter. So now I'm going to monitor it. I'm going to record this session as I recorded the session with the NACS adapter and compare the two. Hopefully we get a full session and it charges from 10 to 50%. If not, we'll talk about what happened. And as I said, I'm going to keep measuring the temperature of the cable and also the connectors on each end to see how hot it gets during this charging session. Okay, we're 5 minutes in. The Lightning is still charging. We're up to about 20% now. And let's measure the cable. So the connector's 127.5 degrees. That's the CCS end. Yikes. 143.5 is the NACS end of the connector. And that's not the Tesla connector. That's the NACS end of the Hansshow adapter. So I got 132.5 degrees Fahrenheit for the cable. It was right around between 125 and the highest I saw was 137. So right around the low 130s for the cable after 5 minutes of charging. Let's see what happens after 10 minutes of charging. All right, so we're 10 minutes in now. We're only up to 27% state of charge. The Lightning significantly lowered its charge rate. It didn't hold the full 500 amps as long as it normally would. So I'm assuming the Hansshow Extension cable hit some sort of thermal limit and had the charging rate lowered, because the Lightning should have been pulling its full amperage for longer than that. Let's see what the cable is now. 130.5 for the NACS end. $129 on the CCS side, and the cable sorry, I'm in the middle of shooting a video right now, is 132.5 degrees Fahrenheit. So it's still charging, and it's still, you're kind of right below that threshold, the 140 degree Fahrenheit threshold for the UL 2252 protocol. So it's, even though it's in direct sunlight, it is staying under that 140 degree Fahrenheit threshold. We'll monitor it and I'll check back in after 15 minutes of charging. All right, so we're 15 minutes now and we're at 35% state of charge. Let's check the temperatures. The CCS connector is 138 degrees Fahrenheit. The NACS end is 132.5 degrees Fahrenheit. And the cable's 133.5 degrees Fahrenheit. Now, as a comparison, let's see how the Tesla cable and connector's doing. 93.5 degrees Fahrenheit. 114 degrees Fahrenheit for the Tesla's NACS connector. So the Hanssshow's cable and connectors are significantly hotter than what we see on the Tesla Supercharger, but that's to be expected because this is cooled and that connector isn't. So we'll check back in 20 minutes. Hopefully we're still charging at that point. All right, 20 minutes in now and we're up to 41% state of charge. So we got 31% in 21 minutes, which is definitely slower than what I would see if I just had a NACS adapter. Let's check the temps again. Now we're up to 140 degrees Fahrenheit on the CCS1 end. Wow. The NACS end is 147. So both ends of the connector have reached and exceeded the limit that UL sets for the surface temperature of any type of charging adapter. The cable, 135.5. And as a comparison again, the Tesla connector is 128.5 degrees. And the cable is 92.5 degrees. All right, things are heating up here, but we're still charging. We'll check back in 5 minutes. All right, 25 minutes of charging in. We're at 46% state of charge. Let's check the temps. Can't get a good reading. There you go. 142.5 on the handle. Yeesh. 156 on the NACS connector end. $136.5 on the cable. Now we'll look at the Tesla. 117.5 on the NACS end of the Tesla cable. 92 degrees on the cable itself. So we're still charging, albeit slower than if I just used the NACS adapter. The biggest problem here, in addition to the fact that if I unplug this right here, the charging session will continue until I separate those connectors. That's the hugest problem. But the secondary problem is we're finding that this extension cable is exceeding the standard set by UL 2252 for surface temperature. So it's got two problems here. I tell you, I am tempted to see what happens if I press that button and pull them apart. Tempted, but not stupid enough to do it. I'm sure it would make a great video and maybe a killer thumbnail, but killer is the operational word there, because I literally could die if I did it. I probably wouldn't, but I could, at the very minimum, I could really get injured. Don't anybody disconnect this thing while it's working. That's why there needs to be a micro switch in that, where as soon as you press that switch, charging stops before you have the opportunity to pull it. If I just press that switch in and pull these apart, really bad things will happen. All right, well, this should be the last check-in until I'm at 50% state of charge. We'll see what we're at the final. All right, so charging is complete. I just unplugged it, and this thing is super hot to the touch. Let me see what we have here. Okay. 131 it said, but now it says 128. You can see the 131 on the bottom. The cable itself. Shoot. It's only 121, and the NACS connector is 126.5. So it cooled off a little bit after I unplugged it. I don't have the final time of the charging session, but it looks like it was probably around 28 or 29 minutes. So about 5 minutes slower than my session with just the NACS adapter, which wouldn't be bad if somebody has this extension cable. Time-wise, it's not bad. It's all the other issues that I'm mostly concerned about. But it was able to complete the 10 to 50% charging session on the Lightning. It was not able to complete it on the Rivian. And I tried a few times, and Rivian just wasn't going for it and just kept shutting off. So I guess the Lightning is a little more tolerant of temperature than the Rivian is. So, all right, well, let's go back to the State of Charge garage and talk about the results. Okay, so it did work with the Lightning. It was able to charge from 10 to 50% without any interruption, although some of the surface temperatures are of concern that would have exceeded what the UL 2252 protocol calls for. But those aren't for field testing in direct sunlight. That, I'm sure, added to the surface temperature. I'm pretty sure when they test those conditions, it's in a lab and without direct sunlight, adding to the heat. So if it wasn't outside in the sun, we probably would have stayed under that threshold. I don't know for sure, but I do know it got really hot testing it outside in the sun, and exceeded what the UL wants the surface temperatures to be. All right, so now let's take a look at the comparison between my 10 to 50% charging session using the NACS adapter and the 10 to 50% charging session using this extension cable. Okay, so this was done at the same supercharger location, even the same stall. And I went from 10 to 50% in 24 minutes using the NACS adapter, and it took 30 minutes using the Hansshow extension cable. So that leads me to believe that at some point during the charging session, the charging power was reduced, perhaps because the Tesla Supercharger sensed that there was a temperature issue at the connector end, so it lowered the charging rate for a little while. It worked, but it did take 6 minutes longer than it did with the NACS adapter. And just to be extra thorough, I tried the cable out one more time with my Rivina R1S back up at the Hansshow Supercharger, and I had pretty much the same result. It charged for about 9 minutes and charging stopped. I didn't get the warning that the inlet was too hot and that I needed to let it cool off, charging just stopped. So there is some issue with the Hansshow and the Rivina. The Rivina just doesn't want to accept energy for a long period of time with this unit having the electricity pass through it. So what are my final thoughts on the Hansshow extension cable? I can't honestly recommend it at this point. It's not something that I would like my followers to use in its current iteration. Could Hansshow improve upon it and make it something that is worthwhile to consider? Certainly. Number one, they have to, in my opinion, immediately upgrade the switch here to have it shut off charging as soon as that red button is pressed. I honestly don't think they should continue selling them at this point. I know that they have it in the instructions clearly that you don't use that to separate the connector from the extension cable while charging is occurring. They tell you to use the switch or shut the vehicle charging off from inside the vehicle or your app. But people just don't follow instructions. We know that. Or what if somebody walks by and presses it? I know you're not supposed to, but people do that all the time. What if a kid's walking around the supercharger area unsupervised? That's why things have to be built safer than what they really need to be, just in case these edge cases happen. So I don't think it should be sold with the fact that that switch doesn't immediately shut off charging. That should be a relatively easy fix. And then we'll talk about the 240 amp limit. Pretty much every electric vehicle sold today draws more than 250 amps. Now that's not really a limit. That's what they're saying it's rated for. I would imagine for continuous load. But that doesn't mean it can't have a short period of amperage draw over that, like a boost period. That's how many adapters and so forth work. This, I'm sure, can handle higher current for a short period of time before there was any type of a thermal limit. And you could see with my Lightning, at least, it pulled the 500 amps for a little while. It did reduce the charging rate, or the charging rate was reduced. I don't think it was from the cable. I think the supercharger did that because the connector was getting too warm at the end where it mated with this side. But it did lower the charging rate, which doesn't typically happen for me when I charge my Lightning at Tesla Superchargers. And I've been up to that Rockaway Supercharger a few times with it, and it didn't lower the charging rate. It charges in 10 to 50%, as you saw, in about 24 minutes. So something's going on that's causing the charging station to throttle back its power. I think that this should be rated for a minimum of 350 amps. And I think then it would be able to handle the boost of the 500 amps that many electric vehicles draw today for up to 10 minutes, sometimes even a little bit longer. I just think that if I were to be using this on my Rivian and my Lightning, every time I plug in, because I only plug in at a very low state of charge, both vehicles are going to pull 500 amps for like 10 minutes. So, or they're going to call for 500 amps for like 10 minutes. So much of the use of this would be at double the rated amperage. And I would suspect that over time, there could be problems with it because of that. I'd feel much better if they said it was rated at 350 or 380 or 400 amps. Now I know I'm only exceeding the rating by 20% or so, right? Charging at 500 amps, I'm exceeding the rating by 100%. I'm asking for twice as much as it's rated for. And as I said, many electric vehicles today are going to call for 500 amps. So I think that should be fixed. So two things for sure. As far as surface temperature, UL 2252 states that non-metallic surfaces that you would reasonably expect you to touch, which would be this entire unit here, should have a maximum surface temperature of 140 degrees. We saw that it went over that, but I was charging in direct sunlight, so that has to be taken into consideration. If this was being done inside and there wasn't direct sunlight baking on it, perhaps those temperatures would have stayed down below the 140 degree UL 2252 limit. I don't know that for sure, but I know it exceeded it in the one test that we did, so that's not good either. So, you know, Hansshow could probably make this a safe extension cable that I wouldn't have a problem using. But in its current form, as far as I'm concerned, it's not. And I wouldn't recommend this to my followers. You know, the $599 is expensive, but don't forget you do get the integrated CCS1 connector. With the other extension cables that are on the, well, not on the market yet, but that are in development, it's just the cable. And then you have to buy the NACS adapter for the other end. And I've talked to the other cable companies about why do you not integrate the CCS1 connector on the end? Why wouldn't you make it in this form factor? And their answer was that certification, that they don't believe that they'd be able to get it certified if it was one unit like this. This is not safety certified. So that's another thing that you have to consider. I don't know the safety certification process. If they're telling me the truth, that they wouldn't be able to get it safety certified if there was the integrated connector, but that's what I'm told, the reason why they're not currently trying to engineer cable with the CCS end. It's just going to be NACS female to NACS male, and then you attach the CCS, the NACS to CCS adapter on the end, and that's how the extension cable is going to work. But as I said, again, no other company is currently selling them. This is the only game in town. If you absolutely need one, this is the one that you're going to get. Again, as I said, I'm not recommending it. I'm not going to have any sort of affiliate link or anything with the company. I will drop a link to purchase this in the description of my video, but that's not any type of affiliate link. It's just a hard link to their website. If you order it, I don't get any type of commission or anything like that, which I do on some of the products that I review here on State of Charge. But in this form, I'm not comfortable even getting a commission from sales on this product. So, but again, as I said, I think with some improvements, they can make it so that I would, but it's not the case right now. And hopefully Hansshow goes back to their engineers, makes a few changes, and makes the product something that I could tell you guys that I'm comfortable with you using. But until then, it's not something that's going to go on my recommended list. So listen, I hope you learned a little bit here about this product and it helped you decide if you want to buy it or not. Of course, I'm not the only game in town. There's other reviews of this product online. I try to do the most thorough reviews out there, but there are other people reviewing them. You could check on YouTube. Brendan Flash has a review of it. There's a few other YouTubers that have reviews of it. Some of them endorse it and say that, yeah, I think it's great and you should buy it, but that's for you to decide. So I urge you to watch a few videos out there before you make a decision. And ultimately, that's on your shoulders. So listen, if this is your first time here at State of Charge, please hit that subscribe button and ring the notification bell so you don't miss any upcoming electric vehicle news and reviews. And as always, thanks for watching.